Good morning, class. So today we're going to expand on what we talked about yesterday, which was a review of basic systems of equations that you covered in Algebra 1 and Algebra 2. So today we're going to take it a little bit further and look at more complicated systems of equations with more variables and more equations. All right, so we're going to start easy. With what is called backwards substitution. All right. So, of course, when we were looking at two variable equations, we were trying to solve for x and y. All right. Well, here we're looking at three variable equations, so we're going to solve for x, y, and z. All right. And just for those of you that have never seen it before, all right, the z-axis is actually the three-dimensional axis, and that's what makes you be able to graph points, lines, anything in three dimensions. All right, so basically we're trying to find a ordered triple, which is a point in space. All right, so here, this is very basic. All right, and what we're going to use here, like I said, was called backward substitution. So we want to find x, y, and z. All right, well, as you can see, we already know what z is, right? So we've already found z. All right, well, it's called backward substitution because now we can go backwards up to this equation above and plug in the z that I know for z and solve for y. So now I will have y plus 4 times z, which we know is 2, and that has to equal 7. All right, so when we do that, right, 4 times 2 is 8. We subtract 8 from both sides. Y is equal to -1. All right, well, now that we know z and y, we can go back up to my top equation here, all right, and plug that in. So I know that I'm trying to find x minus 2 times y, which I just found to be -1, plus 3 times z, which I know is 2, and that is equal to 9. So, of course, -2 times -1 is +2. 3 times 2 is 6. 2 plus 6 is 8. All right, so that's x plus 8 is equal to 9. Subtract 8 from both sides. X is equal to 1. All right, so we found our ordered triple. That would be x, comma, y, comma, z. Right, just like we would put our solution as a point of intersection with two variable equation. All right, then we do the same thing, similar thing with a three variable equation. We just call it an ordered triple instead of an ordered pair. But it goes x, y, z. All right, same concept here. All right, so I know what my z is. So I can go ahead and plug that in up here. And we are going to get y plus 3 times z, which is 3, is equal to 6. 3 times 3 is 9. Subtract 9 from both sides. Y is equal to -3. Now I plug my z and my y in up in my first equation here. So I'm going to have 2x minus y, which is -3, plus 5 times z, which is 3, equals 22. All right, so 2x, -3 is +3, plus 5 times 3 is 15, so 3 plus 15 is 18, so this is plus 18 is equal to 22. Subtract 18 from both sides, so 2x is equal to 4, which we know x is equal to 2. So my ordered triple here, 2, comma, -3, comma 3. Done. All right. So, when we're giving that to us in this form, it's really, really easy. We just use backward substitution. All right. Now, what it's actually called when we're given it in this form, that's called row echelon form. So, actually, reduced row echelon form, but we'll get to that in a moment. Okay, so now we're going to talk about how to solve them when they're not in that nice, neat form, and it's called Gaussian elimination. All right, so two systems of equations are equivalent when they have the same solution set. Right? To solve a system that is not in row echelon form, first convert it to an equivalent system that is in row echelon form by using one or more of the elementary row operations shown below, which is actually on the next slide. This process is called Gaussian elimination, after the German mathematician Carl Friedrich Gauss. All right, and these are the elementary row operations that we are allowed to do, and these are the only things that we are allowed to do. Lots of students try to make up things that they can do. All right, this is it. These are the only three things that we're allowed to do. We're allowed to interchange two equations. Right, so if we want to move, the third equation up to the top and put the top equation down at the bottom, that's perfectly fine. We are allowed to multiply one of the equations by a non-zero constant, right? And we are allowed to add a multiple of one equation to another equation. All right, so let's take a look. All right, so basically, all right, to get it in row echelon form, all right, we're going to want to go ahead and we always want this to be a 1, all right, and then we want this to be a 0, 1, and then we want this to be a 0, 0, 1, okay, which will get it to that form where we kind of just saw it, all right. So this is already a 1, so we're good. We don't have to change this equation at all. All right, now I want this to be a 0, okay? So, and what you really have to do here, all right, is you have to be very specific in telling me what you're doing, all right, because, 10 different people could do this 10 different ways and all get to the correct solution differently. So if you don't tell me exactly what operations you're doing, all right, then I can't follow your work, all right, which means I can't give you credit for your work. All right, so for example, we want this to be a 1. It already is. So I'm going to call this E1 for equation 1. I'm going to call this E2 for equation 2. And I'm going to call this E3 for equation 3. All right, so since this is already a 1, I just leave it. So I'm going to go ahead and leave E1. So that's x minus 2y plus 3z is equal to 9. All right, now I want this to be a 0. All right, well, one of the things that we're allowed to do, all right, is add rows or add equations together. All right, so to get this to be a 0x, I can simply add equation 1 plus equation 2. All right, and when I do that, negative x plus x gives me 0x, which is what I want. All right, negative 2y plus 3y gives me 1y. 3z plus z gives me plus 4z. And 9 plus negative 2 gives me 7. All right, well, now I also want this to be a 0 as well. Okay, so there's a couple of different ways that we can do this. I'm going to go ahead and say 2 times equation 2 plus equation 3, because that'll give me a negative 2x plus a 2x, which will give me the 0 that I want. Okay. To be in row echelon form, your coefficients have to be a 1, and then it doesn't matter what comes after that in my first equation. And then it has to be a 0, 1, and I don't care what comes after that. and then it has to be 0, 0, 1, and then we don't care what comes after that. All right, and then that puts it in that nice form where we can just do backward substitution. All right, so if I do 2 times equation 2 plus equation 3, all right, that gives me negative 2x plus 2x, which gives me the 0 that I want. All right, this will give me 6y plus negative 5y, which will just be 1y. This would be 2z plus 5z, which would be 7z. All right, and this would be negative 4 plus 17, which would be 13. All right, so we're good here. All right, now my first equation is good, my second equation is good. All right, so, and when we talk about equation 1, equation 2, equation 3, all right, it's always from the most previous iteration of work. Okay, so now this is my new equation 1, this is my new equation 2, this is my new equation 3. Okay, so my equation 1 is fine because we just want a leading coefficient of 1 there, so I don't have to change that at all. So x minus 2y plus 3z is equal to 9. All right, my new equation 2 has coefficients of 0, then 1, which is exactly what I want, so I don't have to change that either. So now I just have y plus 4z is equal to 7. All right, and now I want this to be 0, 0, 1. Okay, and the most important thing is to get this to be a 0 first. We can always get this to be a 1 later. Sometimes it works out nicely, like which I believe it will here, but it doesn't always. So don't worry about, like, the only thing that you can kind of do is the zeros first and then the 1, and then, you know, so do be mindful of that. All right, so to get this to be a 0, all right, I could just do equation 2 minus equation 3, but I'm actually going to do equation 3 minus equation 2, just so that these end up being positive numbers. It doesn't matter. It doesn't matter at all. But sometimes it's just easier to work with positive numbers. All right, so write that out, right? All right, so we're going to want equation 3 minus equation 2. And when I do that, of course, 0 minus 0 is still 0. Y minus y is also 0. 7z minus 4z is 3z. All right, and 13 minus 7 is 6. Okay, now, if you kind of see where this goes and what I'm going to have to do to get this to be a 1, all right, you can kind of come out here and change this thing, right? We could actually just say, all right, well, I'm obviously going to have to, essentially I want to divide this by 3, but we're not allowed to divide equations, quote unquote, but we are allowed to multiply equations by non-zero constants. So why don't I just take this whole thing, E3 minus E2, and multiply it by 1/3. So now when I do that, 1/3 times 3z is just z, and 1/3 times 6 is just 2. Okay, so now I have this whole system, right, in row echelon form, kind of what we just did in the previous couple of examples. Well, now I can just use my backward substitution to solve, right? Well, I know that that z equals 2, so now I can say, okay, well, y plus 4 times z, which is 2, is equal to 7. That's 8. Subtract 8 from both sides. Y is equal to negative 1. All right, so now I can plug y and z into my top equation here. All right, and I can have x minus 2 times y, which is negative 1, plus 3 times z, which is 2, and that equals 9. All right, well, negative 2 times negative 1 is 2. 3 times 2 is 6. 2 plus 6 is 8. So x plus 8 equals 9. All right, so subtract 8 from both sides. X equals 1. So now I have my x, my y, my z. So I know that the solution to this set is 1, negative 1, 2. All right, so this is all very new to us. All right, so it's definitely going to take some practice. All right, so what I suggest you do here, all right, is pause the video now, try this on your own, all right, and then once you either A, get to what you think might be the solution, or B, if you get really stuck, all right, then go ahead and play the video and check yourself to see whether you got it correct, or kind of see where you got stuck and where you need to go. Now, do be mindful, like I said earlier, that I may do this one way, you may do it a completely different way. We may get to the same solution set. That's fine. All right. None of the steps here are extremely complicated, right? But it is a lot of, I call it bookkeeping, right? Like you have to be very careful when you multiply equations to multiply the whole equation. Make sure you don't make any silly little mistakes with that, or sign mistakes or anything like that, because one little mistake will kind of mess up the whole thing. Okay, so here again, I want my first equation to have a coefficient of 1, and then we don't care what is after that, and that's what happens. All right, so I don't have to change equation 1 at all. All right, so this is x plus y plus z is equal to 6. All right, I want this to be a 0. All right, so I can do that by saying 2 times equation, or I can even say negative 2 times equation 1. Then that'll give me negatives. Not that it matters, right? I don't want you, just sometimes it makes it easier for a lot of people. So it's going to give you negatives either way. All right, so 2 times equation 1 minus equation 2. All right, so 2 times x is 2x, minus 2x gives us the 0 that I want. All right, then I'm going to have 2 times y is 2y. All right, minus a negative y is the same thing as plus y, so this will become 3y. And 2 times z minus 1z is just z, so plus z. And 2 times 6 is 12, minus 3 is 9, so this will equal 9. All right, again, now I want this to be 0. All right, there's multiple ways. We could multiply this by 3 and multiply this by 2, the whole equations, of course, one of them by a negative, and then add them together. I always like to use the first equation in my first round of steps. Don't try to jump ahead of yourself. All we're trying to do is get this to be a 0. We'll worry about this being a 1 later. Okay. Well, actually, we'll want it to be a 0 also, since it's the third equation. But you can't really do that all at once necessarily. Sometimes you get lucky and it happens. All right, but don't like kill yourself trying to get to that point, because a lot of times you can't. All right. So what I'm going to do here is say 3 times equation 1 minus equation 3. All right, so 3x minus 3x gives me the 0 that I want. 3y minus y gives me 2y. 3z, oh, actually, wait a minute. 3y minus negative y actually gives me 4y. So I almost made one of those silly mistakes that would have messed us up significantly. Wait a minute. No, I did that right. Okay, so getting back to it here. All right, we're doing 3 times z is 3z, minus a negative z is plus z, so this is 4z. And 3 times 6 is 18, minus 2 is 16. Okay, so now we got these to be zeros, which is what we want in our first, I call them iterations. Okay, so now to be in row echelon form, I want to have 1 as my first, which I do, so I can leave this E1. So x plus y plus z is equal to 6. Remember, this is my new equation 2. We just call this equation 2 now. We don't call it 2e1 minus e2 anymore, right? Or things get really, really messy. And I want this to be 0, 1, right? Well, this isn't a 1, all right? And if I try to combine this in any way with the first equation, it's going to end up giving me an x term again, which I don't want. So once I get past that first step, I'm really going to ignore my first equation from that point on. Right, but what I can do here is equation 2 minus equation 3, and that will give me the 1y that I want. So equation 2 minus equation 3. All right, so of course 0 minus 0 is 0. 3y minus 2y is the 1y that we want. All right. Z minus 4z is negative 3z, and 9 minus 16 is negative 5. All right, so we're good there. All right, for my last equation here, I want it to be 0, 0, right? I don't want an x or a y, okay? So in order to do that, I'm going to have to eliminate my coefficients of my y. So I'm going to multiply this by negative 2 and this by 3 and add them. Okay, so negative 2 times equation 2 plus 3 times equation 3. All right, and when I do that, all right, I will get negative 6y plus 6y, gives me the 0 that I want. Negative 2z plus 12z would give me 10z. And then negative 18 plus 48 would give me 30. So now I know here, to get this to be a 1, I'm essentially going to want to divide by 10, which is multiplying by 1/10. So if I multiply this whole thing here by 1 over 10, whoa. All right, then I can make this the 1z that I want, and I can make this a 3. All right, so now it's in row echelon form. I can go ahead and do my backward substitution. All right, so I know my z. I can plug it up in here to my second equation. So y minus 3z, which we know is 3, is equal to negative 5. So this is negative 9. Add 9 to both sides. So y is equal to 4. All right, and then up here we have x plus y, which is 4, plus z, which is 3, is equal to 6. 4 plus 3, of course, is 7. Subtract 7 from both sides. X is equal to negative 1. So our ordered triple here is going to be negative 1, 4, 3. Okay. You can go ahead, and if you really want another practice problem, you can go ahead and do this one. Again, it's not super important that you see me work it out because it's so kind of subjective how you do it. Like I said, 10 different people could do them 10 different ways, all right? And everybody could get it correctly. So all I'm going to do here is give you the answer so that if you really want to try this, you can at least check yourself. And I'm just using my calculator to do this, using matrices. All right, so give me just a moment here, and eventually, when we start solving these using matrices, I'll teach you how to do this as well. Okay, so this one doesn't work out quite so nicely. All right, so our answer here, I believe, that doesn't work out. Okay, well, let's just go ahead and do this because the calculator is giving me something that I don't like, so we'll see why. All right, so I'll go through this one a little bit more quickly instead of kind of explaining every step by step, but just showing you like what I'm doing to each equation and how I'm getting the next equation should allow you to follow relatively well. All right, here my leading coefficient is a 1, so I don't have to change this at all. All right, so 1, -3, oops. I'm jumping to using matrices already, getting ahead of myself. All right, so x minus 3y plus z is equal to 1. I want this to be a 0. All right, so I'm going to go ahead and say 2 times equation 1 minus equation 2. All right, so 2x minus 2x is 0. Negative 6y plus y is going to be negative 5y. 2z minus negative 2z is going to be 4z. And 2 minus 2 is going to be 0. All right, so now I want this to be a 0 as well. I can just go ahead and say E1 minus E3. All right, so x minus x gives me the 0 that I want. Negative 3y minus 2y gives me negative 5y. All right, and z minus negative 3z gives me plus 4z. All right, and 1 minus negative 1 is 2. And now I see why my calculator was giving me something funky. Okay, so I want this to be a 1, but for now I'm going to go ahead and kind of skip that step until the very end, because then it's going to give me messy fractions. Okay, so I'm going to keep E1, and that'll be x minus 3y plus z is equal to 1. I'm going to keep E2, all right, and that will be negative 5y plus 4z is equal to 0. All right, and now I want this to be a 0. All right, well, these have the same number, so really all I have to do is subtract them, right? I can just say E2 minus E3. So, of course, 0 minus 0 is 0. Negative 5 minus negative 5 is also 0. 4 minus 4 is also 0. So everything on this side cancels out, right? And then 0 minus 2 is negative 2. Okay, well, can 0 equal negative 2? Absolutely not. Right? When that happens in two equation, two variable systems, right? All we say is that there's no solution. Same thing happens here. All right, so this is no solution. So I'm glad we worked that one out. All right. Again, you might want to pause, try this one. Again, I'm just going to go ahead and use my calculator to give you the answer. I have a very strong suspicion that this is going to be another no solution. All right. Yep, this is another no solution. All right. So basically, with throughout the process of trying to get it in row echelon form, you should get that contradiction somewhere, right? Where, like here, we got 0 equals -2, right? That's called a contradiction. So at some point doing this, you'll get that contradiction. Okay. So the number of solutions of a linear system, and with these larger, uh, you know, 3-equation, 3-variable systems, we're only going to be doing linear. Right? Although it has a z in it, it's actually, if you were to graph it, it's still just a line, but it's in 3 dimensions. Okay. So just like with 2 dimensions, when you're doing systems of equations with just linear systems, linear functions, all right, there's only 3 possibilities. All right, there's exactly one solution, which is one point of intersection. There are infinitely many solutions, which we have yet to see, or there is no solution, which we just saw. All right. However, the infinitely many solutions are a little bit different in 3 dimensions than they are in 2 dimensions. Right? Instead of just saying, oh, there's infinite solutions, right? There are going to be infinite solutions, but they're all going to be of a certain form, and we're going to have to find that form. All right. So let's go ahead and show you what I mean by that. Okay. So if we go ahead and try to get this in row echelon form, this has a leading coefficient of 1, so I don't have to do anything to it. So x plus y minus 3z is equal to -1. All right, this has a 0, then a 1. Awesome. Don't have to do any work for that either. All right, so I can just leave this e2. So this is y minus z is equal to 0. All right, now I want this to be a 0. So I have a +1 here and a -1 here, so I can just add those, right? So e1 plus e3. So 1 plus -1 gives me the 0 that I want. Y plus 2y gives me 3y. -3z plus 0 is -3z. And -1 plus 1 is 0. Okay, well, again, my first 2 equations are perfectly fine. So I have x plus y minus 3z is equal to -1. And we have y minus z is equal to 0. Now I want this to be a 0. So I'm going to say 3 times equation 2 minus equation 3. 3 times equation 2 minus equation 3. So when I do that, of course, 3 times 0 is still 0, minus 0 is still 0. 3y minus 3y gives me the 0 that I want. -3z minus -3z gives me another 0, actually. So all of these become 0 on the left-hand side. So I just put a 0 there for a placeholder. All right. And of course, 3 times 0 is still 0, minus 0 is 0. Okay, so here, right, we eliminated all of our variables, but we didn't get a contradiction, right? This isn't something that's not true. It's something that is true, okay? However, we can't just say infinite solutions and be done with it, right? What we actually have to do here, all right, is find what's called the form of the solution set, the general form, all right? And how we're going to do that basically every time, right, is we're just going to start by saying, okay, let's let z equal some number a. We don't know what number that is, it's just some number a. Okay, well now I can go ahead and do my backward substitution stuff. So now I'm going to use this. I'm going to say, okay, well, that means that y minus z, which we now know is a, is equal to 0. So I add a to both sides, y also equals a. All right, and then I can plug both of those into the first equation, and I get x plus y, which is a, minus 3 times z, which is also a, is equal to negative 1. So a minus 3a is negative 2a. So if I add 2a to both sides, we get x is equal to 2a minus 1. All right, so my general form of my solution set here is actually going to be 2a minus 1, comma a, comma a. All right, so really what this means is that you can pick any number you want for a. Let's let a be 1. Okay, well, 2 times 1 is 2, minus 1 is 1, and then of course 1, 1. So 1, 1, 1 would be a solution set. Okay, you could let a equal 2. So if you did that, you would get 4 minus 1, which is 3. So 3 comma 2 comma 2. That would be a solution, right? There's going to be infinite solutions. You can let a be whatever you want, and then whatever you get for those numbers when you plug them in here, that's going to actually be a solution. Okay, so there are infinite of them. They're just not. It's not like with the two variable two equation systems where like everything is a solution. There's still infinite of them. There's just only of a certain form. All right. So let's look at one more of those. Again, I highly recommend that you go ahead and pause this right now. All right. Work on this yourself, and then if you get stuck or if you actually get it, play the video and check yourself. Okay, so this one looks kind of long here, but that's all right. This has a leading coefficient of 1, so that's perfectly fine. I don't have to change equation 1. That's just going to be x plus 2y minus 7z is equal to negative 4. All right, I need this to be a 0, so I'm going to say 2e1 minus e2. All right, so 2x minus 2x gives me the 0 that I want. 4y minus 3y gives me 1y. That's convenient. I want that to be a 1 anyway. All right, negative 14z minus z is negative 15z. All right, and negative 8 minus 5 is negative 13. All right, here I also want this to be a 0. All right, I'm kind of looking ahead a little bit, so I'm actually going to do E3 minus 3E1. And that's just because I've kind of noticed that if I do that, 7y minus 6y is going to give me 1y positive instead of a negative. But it doesn't matter. All right, don't think that you have to think ahead and do that. All right, so here I'm going to get 3x minus 3x, which gives me the 0 that I want. I'm going to get 7y minus 6y, which is just going to give me y. All right, I'm going to get negative 36z plus 21z, which is going to be negative 15z. All right, and negative 25 plus 12 is going to be negative 13. All right, so whenever we get these bottom two equations that are going to be exactly the same, that's when you know this is going to happen, right? Because now, right, I know that my E1 is fine. I know that my E2 is fine. So I'm going to have x plus 2y minus 7z equals negative 4. I'm going to have y minus 15z equals negative 13. All right, and then of course I can just do equation 2 minus equation 3. And when I do that, right, I'm going to get 0, 0, 0. So that's just going to be 0. And then negative 13 minus 13 is also 0. Right, so that's how I know I'm going to have infinite solutions. So I do the same thing here. I say, okay, let's let z equal a. So now when I take this second equation here, y minus 15a is equal to negative 13. So y is equal to 15a minus 13, which is a little messy, right? But that's okay. And then we go up here to equation 1, and I know that x plus 2 times y, well, y is 15a minus 13, minus 7z, we know that z is just a, is equal to negative 4. So now I just simplify and solve this for x, right? So x, this is going to be plus 30a minus 26 minus 7a is equal to negative 4. All right, so 30a minus 7a is 23a. So x plus 23a. If I just add 26 to both sides, I'm going to get is equal to 22. So x is equal to, I subtract 23a from both sides, negative 23a plus 22. All right, so my solution here is going to be a bit messy, but it's okay. Right, it's going to be negative 23a plus 22, comma, 15a minus 13, comma, a. So again, you can pick any number you want for a, and you can easily get an x, a y, and a z that will be a solution. And of course, there's infinite of them because you can plug any number you want in for a. Again, that's called the form of the general solution. Okay, I believe that is all we have for today. Yep. Of course, your assignment is on Delta Math. Should be shorter and a little bit easier than this, so hopefully it won't take you too terribly long. If you have any questions, please get a hold of me. I'll get back to you as soon as I can.